So we were talking about the cubic equation of state for the gas phase. We already have written in terms of pressure. Now we are talking about how to write in terms of volume and how to write in terms of compressibility factor. So where the values of the beta is equal to omega PR over TR, Q is equal to psi alpha TR over omega TR. So these values you can get it from the appendix from the table 3.1. This is for van der Waals question. The values are alpha TR is 1, sigma is 0, epsilon is 0, omega is 1 over 8, psi is 27 over 64. This is ZC value. So RK, this SRK, we can also get it from the table, from the book as well. I will also share with you this table. So I recommend you, if the pressure is given and temperature is given, then if pressure is given and temperature is given, then you have to practice use the compressibility factor relation, because there are two advantages of this one. One is the Z is dimensionless, Z is dimensionless. This is the plus point. The second the thing is we have to use this Z equation throughout rest of the thermo course, chapter 6 and then chapter 11 and maybe 13 as well, but mostly the 2-3 chapters we have to focus on this. We have to calculate first Z, then we can find other parameters. So it means this is very important. So and we also you can calculate, but I don't recommend you to go with it. I told you Z is dimensionless, and also we have to use for the rest of chapters. We will just find it only in this chapter. So you can easily, you can, if you know the Z value, you can easily find the V. So it's not a big problem. You can easily find by this way. So let's see, because this question is applicable for both gas phase and liquid phase. So we can also write down these two questions in terms of liquid phase. So V equal to V plus epsilon B over V plus sigma B RT plus BP minus VP over AT. Where initial gas is same, the initial gas is V is equal to B. This is your initial gas. And so similarly we can write, I told you again, we can better if you can use the compressibility factor relation. Again, this is dimensionless and you will not face any problem regarding the units. So where beta is equal to, where Z is equal to beta initial gas. So again, for this question, if I told you better to use this one, so I recommend you to solve by this way, because you have to solve for the rest of the chapters. So in both cases, you have to do the same technique as we did for the varied equation of state. We have to iterate. Nobody will just use solver and get the value. So you will lose mark if you do like that. If you use the solver, you have to show all values. Only 3 significant figure is enough in order to solve the problem. The values of Z, like if you can find the value of Z, I can just give you example over here. So Z like 0.973. So no need because when you solve you can get a long value. So this is just example. Okay, so this for the liquid, for the vapor phase you are getting the value close to 1, maybe 0.8, 0.7. But for liquid phase the force of traction between liquid is very strong, so you will get very small volume, so your z generally will be very less, like maybe 0.04, something like that. But in exam you have to show the iteration like z1, z2, z1 is equal to 1, of course, z2 and z3, let's say 0.963, and z4 0.963. When you will see the consistent value you have to stop. Same rules, and if you don't do that you will lose mark for that. Okay, so let's see when we have one example over here and we can solve it. So we have the table with us. So we have the table with us, and this is the table. So we given that vapor pressure, so P sat is given. So you can write here, we have less space. P sat is given for N butane. We have pure component. We are talking about only pure components, with not mixture and not two phases so far. So N butane at 350K. Oh, sorry. N butane, so at, so I can cut it, sorry. So it is 9.4573 bar, and temperature is given 350 Kelvin, as we have N butane. Okay, so there, what else is given? Find the molar volume. So you have to find molar volume for the gas phase, for saturated vapor phase, and for the liquid. They are using word saturated. So saturated, so you must have to use P sat value. Okay, the saturation pressure value. So their PC value is given. You can find from appendix B, and ZC value, oh sorry, TC value is bar 425.1 Kelvin. Okay, so we see the mega value. So what we need to do, let's say for the gas phase, vapor phase, okay. First step is we need to find TR. So the TR value comes out to be, so 350 divided by T over TC, we can get the value 0.823. The second step is PR. So in this case it will be PR sat because we are using saturation pressure. So say P sat over PC, and it comes out to be 0.249. It's dimensionless. Then we can find beta. So you see beta, we are using, we are using RK equation. So you can also write RK. So we are solving the problem by RK equation. So we have to go here RK. What is the value of all these parameters? Epsilon is 0, sigma is 1, epsilon is 0. Then we have omega is 0.08664, and we have psi equal to 0.42748, and we have alpha TR, it is equal to TR minus half. So all these values are given. So what we can do is we can simply plug in value over here. So beta is L omega PR over TR. So omega is given, PR is given, TR is given. So you can easily So in exam you have to show all calculation. I'm just quickly solving because I'm just substituting values here, but you have to show the question, or you can do like that, question with value, or you can just show question with values. I just show the question and then solve the problem.